Welcome back. This video is all about animations. So in iOS, there's a couple of animation frameworks. The most commonly used animation framework is this thing called Vue Animations. So it's based off of UI View, and it's pretty simple. It's essentially you can animate any of these 5 properties here. And so what I'd like to do is I'd like to walk you through these set of use cases. So the reason I've selected these use cases is that these are the use cases that I'm using most of the time. So for example, 90% of use cases, 90% of animations in iOS is some combination of these tasks. And I'm also going to finish up today with showing you the use cases, or at least discussing the use cases that kind of are somewhat common but then fall out of the Vue animation framework, and I'll tell you how to solve those as well. So just to get started, we'll go through these one at a time. So I have here a basic app. All I have is the default single view application, and I've dragged Mr. T, little image view, onto the screen. And I'm going to just try to illustrate these sequence of use cases using this image view. So let me just also drag on a button here, and I'm going to use this button just to start the animation. So just for fun, I'll move Mr. T from point A to point B. So let me just create my outlet, and I'm going to create my outlet for Mr. T. And then an action for my button. So on go button. And then I think I'm done with the view for right now, so I'm just going to concentrate on this file. So UI View Animations, which is the ability to animate a subset of view properties, is basically how do you use this series of class methods. So animate keyframes, animate with duration, and then there's a few more of these, which I'm going to go over all of these. So the default one is just this one. This is the most commonly used one. So I'm going to select this, and then I choose a duration. Like, let's say that I want to animate him from the top of the screen to the bottom of the screen in half a second. And this is just a closure that I'm going to pass in. So I'm going to just hit return to accept this. And then I'm going to say Mr. TView dot center dot y plus equals to, like, say 300. So I want to move him down, and I'm going to see an error in this because and this is just closures in general. It's just reminding me that because it's capturing this Mr. T view, it wants me to explicitly put self, and this is just so that I remember that because I'm doing this could potentially lead to a memory leak. So it's reminding me that in this closure I'm capturing self, and if I had a pointer to this closure that I'm passing in from self, then that would cause a memory leak. So in this case I don't, so I actually don't need to worry about that. Anyway, so I move him down, I guess 300 pixels. Let's see what that looks like. So I hit go, and then in half a second he moves down here. So maybe I'll make this 400, and that's basically the first use case, right? So like moving things from point A to point B is pretty common. Like you've seen this when you see like maybe alert views dropping down from the bottom. You've seen sometimes they have action buttons rising from the top. You see like views sliding in from the right, sliding in from the left. So this is just moving something from position A to position B. So the next use case that we might want to cover is often you want to move something onto the screen while fading it in, or potentially using a transform while also changing its position. So I want to show you how to animate multiple view properties. So maybe I want to kind of create an illusion where Mr. T is, let's say, rushing out of the screen in kind of a 3D way. So not only is he going to come kind of down, but he's going to come towards me. So in order to do that, one kind of trick that you use, and we're going to learn about perspective transforms in a minute, but one trick that you do is in the background, things have kind of a reduced color, or maybe a little bit of an alpha. And then as he moves down, I'm going to increase his alpha. So in the view properties here, I'm going to select this, and I'm just going to give him an alpha of, say, 0.2. Just fade him out a little bit. Just make him look like he's kind of far away. And then inside of here, I'm going to say self.mrtview.alpha is equal to 1. And let's run that and see what happens. So if I hit the go button, then not only does he move down, but he starts to fade in. But it definitely doesn't really have that 3D effect just yet. So that brings me to my next property, or my next use case, which is animating something called a view transform. So view transform is a funny word. It's it's a linear algebra thing, but essentially what it means is scaling, rotating, or translating. And scaling and rotating are the most common. So let's see what that looks like. So not only do I want to fade him in, but I also want him to get much bigger while he's coming at me. And that really gives me the three-dimensional feel. So I'm going to come into the view controller, and I'm going to change a new property. It's going to be called MrTView.transform. And so one little tip with iOS, because iOS has a lot of long words, is if I'm about to set this equal to something, if I option click on transform, that would show me nothing. Documentation is kind of buggy sometimes, but normally this thing would have popped up and it would have showed me that the type was CG affine transform. So what appears on the right is often begins with what the type is here. Now this is true for CG rect, CG size, actually a lot of things. So this actually helps me remember like what this thing on the right is going to be called. So self.mrtview.transform is equal to CG affine transform, and I kind of go shopping here. I can look at all of the transform available to me, and we're going to play with a few of these items here. So just to start off simple, I want to use the scale 1 just to make him bigger. So I'm going to make him, let's try four times bigger for now and see what that looks like. So now I hit go, and he kind of really comes out of the thing here. So now I can maybe I'll make this, tweak this here, come this a little bit faster, and then kind of have him appear as if he's coming out of the screen. So that's cool. This is illustrating a new property called transform, which is just a two-dimensional transform on Mr. T. So not quite perspective transforms just yet. So what I'd like to do now is maybe I'd like to do something when the animation is complete. So completion methods might be useful for often chaining animations. So one kind of thing that designers tend to do is you don't want to animate too many things on the screen at the same time, because if you have too many things, one of the main purposes of animations is to draw your attention to, say, like a button. So like a screen might come in, and then once that animation settles down, then you animate a button into view so that you can, don't forget that this compose button is here. So often you need to either do two animations sequentially or to do something on the completion of an animation. So to demonstrate that, I'm going to show you the next UI view animation method. So UIView.animate, and then I'm going to select this second one. So the same as the first, except for in this case, it has two blocks here, two closures. One is an animation closure. So I just hit enter to accept that, hit tab, hit enter again. And then I noticed that there's this bool. So this bool, like I don't know why Swift does this, because in Objective-C it was different, but they used to actually name these parameters for you to help us realize kind of what they were. So this is a bool is not that useful. It's actually it actually is the variable that tells us if the animation was canceled or if it completed successfully. So I'm going to just copy these in here. And then just pop up an alert view just to illustrate that this worked. Oops. So UI alert view. And just have this pop up dot show. Okay, this is the old style UI alert view, now deprecated to the UI alert controller. But so now after the animation completes, I see this alert view come up. And so the more common thing to do here is not to kind of do this, obviously, but like to chain an animation. So I'm going to come in here, and let's say that I want him to kind of like, I don't know, he's charging me, it makes sense for him to shake his head at me. Why not? And so I want to say schedule some more stuff in here. So here I might do, say, self.mrtview.transform, and then let's see what else we got that. So remember, this is the, if I look at this, I look at the type, CG affine transform. All right, so I type in CG affine transform, and then let's give him a rotation. And so you probably know where this is going, but for some reason, I wish someone explained to me. Engineers love using radians and not degrees. I can't quite figure out what that is, but what that means is if I want to work in something that makes sense, I have to do a conversion here. So let's say if I want him to rotate, I don't know, like 15 degrees to the right, let's say. So 15 degrees times, and I think it's, let's see here, there's a 2 pi and 360 involved, or pi and 180. Either one. So let's see if this is on the bottom. So degrees on the bottom. Okay, so pi divided by 180. So here I'm going to say this is now 15 degrees in radians. Okay, and there's some type issues here. So I'm going to just check the infer typing system. It thinks it's a double. Of course, this wants a CG float because everything in the old system is of this type CG float. They're really the same, but Swift is just super strict about this. All right, so now if I click on this, I can see that this is now a CG float, and this is happy. It's telling me this was never mutated. Great. Okay, so make this a constant. All right, so let's kind of do this and see what happens here. So if I hit go, so remember I wanted his head to be wobbling. So I saw two things that may or may not have surprised you. So the first thing that I saw was weird was that it after the animation just snapped immediately to the next thing. And the second thing that was weird was that I rotated, but my scale went away. So the first one's an obvious fix. You probably saw that coming. But of course, things in this completion, there's no animation here. So if I want this to animate, then I have to wrap this in yet another animation block. So animate with duration, and I'll just go back to that first one and say 0.2, and then set another animation block and copy this in here. Now, the second thing might have surprised you a little bit more. So you were probably expecting these things to stack, right? So they don't, right? Because this is a property. If you look at this, this is overriding what the existing transform is. So what we need to do is actually we need to combine these two transforms together somehow. There's a variety of ways to do that. For example, you could do something like there's another method here, self.mrtview.transform is equal to CG affine. And if I kind of shop around here, I notice that there's actually 2 scale, 2 rotation, and 2 translation methods. And the second set here takes an input transform. So what that does is it takes an existing transform and it just adds the new rotation transform with it. So that, for example, I could do this. And I could say, well, take whatever transform was already in there. I'm not even paying attention to what that was. And then add in this thing right here, this rotation. And so now if I kind of tilt his head, then I could see that it was animated, and actually it it kept the original scale. So there's a second way to do that. And you might use either one, right? So there's this notion, actually let me just create this as var transform or let transform. So if I were to say use concat, I can give 2 transforms here, and of course once you do this you can keep on concating, and then those are kind of maybe the two methods here. So I'll leave that one off for now. And so let's look at our next use case. So I've demonstrated this thing of combining view transforms. And the next use case is animation options like repeat and auto reverse. And there's other animations options as well. So for example, the animation curve that's used. And so by default, you're going to have 4 standard ones. Linear. Designers will tell you never use linear. The default is ease in, ease out. There's also ease out and ease in. So if you're not a designer, if you haven't played with animation curves a lot, you probably don't know what I'm talking about. 90% of animation should just be ease in, ease out. There is also a case, so ease in, ease out means I'm slowly accelerating up to a speed. I'm kind of peaking at that, and then I immediately start to decelerate. So there's another type that's also used, and that's called ease out. Ease out means it starts at immediately a high velocity and then starts to slow down. So situations where you want to use things like ease out is if, let's say that you have a screen coming from the right or coming from the left. You don't want it to ease in. Generally designers like the illusion where it's like this screen's been booking it from like way far away, and then it's just becoming visible now. So they like it to appear very quickly onto the screen and then slow down as it kind of reaches its ending phase. So configuring animation options is the next use case. So let's say that instead of just tilting his head, because I don't think that doesn't feel like Mr. T. So he's coming in here and he's actually going to be shaking his head. And so in order to do that, I want to use another animation. So I'd like to repeat kind of an animation. So I'm going to go UI view dot animation. And then I'm going to use this like third, so 3 of 5 of these animation methods, right? Kind of technique. So 0.2, 0 initial delay, and then UI view animation options. So let's see what is in here. So there's a bunch, right? And so like here's the UI view, here's the curves that I was mentioning. And then what I really want though is just there's a couple common ones. So auto reverse is common, allow user interaction is common, and auto repeat, wherever that might be, or maybe just repeat is common. So let's say that I want to do a repeat and just start with that, right? So here's my animation block, and then I don't want a completion block, I don't think in this case. So I'm just going to grab this and I'm going to throw this in here. Okay, so let me just run that and see what happens. So if I hit go here, then a couple unfortunate things. One, looks like Mr. T's having a seizure. 2 is that like it's still offset, right? So it's not quite the effect that I was going for. So in order to fix that, so if you look carefully at like why does this look so jerky, maybe you already have figured out that what it's doing is it's returning to its beginning state and then doing it over again, which is sometimes what you want. But if it's not what you want, then you want to enable the second option here. So this is just the mask UI view animation options dot auto reverse. And that kind of is like what it's, oh right, I forgot. This is changed in Swift 2, I believe. So I think it wants me to do this. Okay, so if I hit go now, then I can see that it's smoothed out. He's still kind of head cocked to one side. And so what I can do with that is if I were to do UI view dot animate, and then say do this one, 0.2 animations and then a completion. So what I'll do is I'll move him first negative 15 degrees, and then upon the successful completion I'll start this bad boy up, and then as I come in here, let me just copy this, paste this. So I'm going to have him go, say, 30 degrees, just double the distance to the other side. So let's see what happens here. So if I hit go, then I get this kind of Mr. T bobblehead effect, which I guess is kind of funny. So if you look at this code, you can see that it's getting to be a bit of a mess. So the thing that I won't use, so this is a little bit atypical, right? I mean, 80% of the time, it's just going to be a single one of these things. It's a fade in, like an Instagram heart. So it's a fade and a scale, or it's a moving from one place to another. In maybe a rare case, you get a chained animation. You'll very rarely, this is probably like one of the more advanced sequences that you might see. This is obviously not typical in apps, just a little bit contrived to show you, to illustrate kind of chaining animations as well as these options, and then these these transforms. So if you do get in the situation where you see a lot of this kind of chaining, there is kind of alternative. If you look at uiview.animate, so there's another method, animate keyframes, and that's another way to kind of specify a sequence of animations without chaining it. So let's look at what the next use case is. So the final use case is spring animations, and it's just kind of like it sounds, right? Like with iOS 7, I think they introduced an underlying physics engine in iOS, which is still one thing that we have above Android, and we like things to behave like they behave in the physical world, right? It makes it feel like we're dealing with real physical elements. And so there's a lot of libraries that help simulate spring actions that are really handy, actually. I think Facebook has published a few of those types of libraries. So this spring animations is one that's built in by default in iOS. And I'll show you that one as just as a kind of a final touch, and that'll be the last use case that we cover. So let's say that I want him to come down with a little bit of a bounce, a little bit of a spring action before he goes into head rotation mode. I'm going to see this uiview.animate, and it'll be the final one of these that we'll go over. And we'll notice it has two extra parameters, something called a damping, I think it's called damping ratio, right? And then initial spring velocity. So if I want his initial move down, which is this thing in here, I guess he's coming it down 0.2 seconds, so 0.2, no delay. And then damping ratio it's pretty straightforward. It's 0 to 1. 0 is, let's see, 0 is like a slinky. It takes forever to settle down. 1 is like a car spring, right? So it settles pretty much instantly. And maybe I want to choose something like, say, 0.8. So initial spring velocity is kind of like, it's a little bit like the ease in, ease out thing, which is like, what does the spring start at, right? You can start it at 0. Another thing that initial spring velocity will tend to do is it will tend to influence how much overshoot there is before it starts bouncing. So this is just something that you tune. If you go to the WWDC videos, they'll say, well, how do you tune these? Is there some math calculation? It just says just tinker with them until it looks like what you want it to look like. So I will give it, I guess, I don't think I need any options here. Can I do that? And then some animations and a completion here. So I just want the motion downwards to be this initial thing. And then in this, just complete my action here. And so what I should expect to see is I want to see kind of a little bit of a bounce on his downward move. And then let's see, I wonder if I did a copy paste error here. Oops. So the reason I'm doing this printout statement is kind of weird, but it's kind of interesting because you notice the error moved. By me putting this print statement here, it actually changed the error from line 33 to line 27. So the reason that I do that is like the Swift compiler is still pretty terrible. And I don't know why, but these closures really throw it off. And so often like type errors get masked as something like unpredictable. Double is not convertible to float. literal. See, like even then it's saying that, but I don't really believe it. Double is not. So if I were to, double is not convertible to float literal convertible. Huh. Well, I don't know what the issue is yet. So I'm going to just do UIView.animate with durations. I'm just going to try that again just to kind of gut check this. 0.8 CG flow. I wonder if it's this that's from, what if I did like 20.0 here? Nil and then enter. Okay, build that. Okay, so interesting. Double is not floatable. Okay. Wow, weird. Okay, I just went to Stack Overflow and Googled that. And even though I used options nil somewhere below, for some reason Swift is getting tripped up here with that in this particular function. So wanted this open closed thing, which fixed that error. So if I did that over here as well, so I'm going to do that, change this back to a 0.2. Delete that guy. So run this again. And then let's see what happens. So if I, let me restart that. So if I hit go, then very subtle, right? I don't know if you had to see it. It was a little bit of a bounce. And that's what you generally want, right? But like just for illustration here, I'm just going to exaggerate it. So I'm going to exaggerate it by slowing it down a touch. I'm going to increase the spring velocity by a bit. I'm going to decrease the damping. So if I run this, if we look closely, then I saw it like majorly overshoot. And just for fun, there's one more thing I can show you, which is the simulator has a little testing thing because sometimes you really want to zone in on an animation. So I'm going to click on debug and then slow animation, so Command T. And if I hit go here, then I will very slowly see him bounce away here. And then eventually, I kind of assume that he will start turning, but maybe maybe he just got a little tired. So slow animations generally works pretty well. So as I mentioned, and really, I'm really in these like first 3 bullets for use cases most of the time, occasionally going into these like later use cases. And that is kind of the power of the Vue animation framework. It's pretty simple, but also pretty powerful. There are, however, a couple of things that designers will occasionally ask me to do. So this is not super common, but it is kind of reasonable, right? Like, so some designers are really particular about the animation curve. So if you don't want ease out, ease in, then you want to be able to customize the animation curves, and you can't do that in UI View animations. Another thing that's not super common, but occasionally does happen, is animating along a path. And so have you ever seen like a solitaire style animation where something is kind of like bouncing in and then going someplace? So you can't do that with UI View animations. Strangely, and I don't quite understand why, but infinite rotation doesn't work. If you try to do it, then it actually just doesn't move at all. And then finally, we did some transform, but people like 3D transforms often. So for example, like the Airbnb hamburger menu is an example of a 3D transform in a menu. So something kind of sweeping open like a door. And that's something that you can't do with Vue animations. So what's the solution? If a designer does come to you with these 4 use cases, what do you do? So you use an underlying framework called Core Animation. Core Animation is the lower level framework that all of that UI kit in itself is built on top of. And so you may have noticed that like a lot of things start with CG, CG float, CG size, CG rect. So that stands for core graphics. And so there's it kind of alludes to this system that's below your UI kit. Another thing that you might have noticed is that like if I want to round the corners of a view for some odd reason, you go view dot layer. And that layer is that core animation layer. So essentially what happened was, like back in the olden days, everyone used to work with layers and core animation. I think this was maybe around the next step days. And then they wrote UI kit on top of it. And for some reason, for example, they didn't expose rounding corners to the UI view layer for unknown reasons. Anyway, the core animation framework for animating things is more powerful than the view animation. It's a little bit more verbose and a little bit more complex, although at the end of the day, it's still pretty simple. It's still about what's called property tweening, which is like how to get from property A to go from this value to that value. So I won't show you the syntax for this in this video, but in the rare situation where you do need to do one of these 4 cases, then you want to do layer animations via the core animation framework. So that wraps up animations in iOS. Hopefully you get the sense that it's actually pretty straightforward.